Hello, I'm going to talk us through the PowerPoint on the ancient numeration systems and try to hit the highlights as we go through there. So let me use the PowerPoint. I need to share the screen for that. Here we go. And make this much bigger. Okay, there are four systems that we're going to take a look at: the Mayan system, Egyptian, Babylonian, and Roman systems. And all of these are from different civilizations at different times in the world at different places. I chose them not because they're the only ones. There are lots of numeration systems that we could take a look at. In fact, you could do a whole course on ancient numeration systems. But these four have some interesting properties, and they're different from each other in some ways that make them good examples to take a look at. Okay, and of course, the fifth one that we live and breathe every day is the one that we use, and it's called the Hindu-Arabic system. So if you can kind of remember back to when you very first started doing any math, you probably don't remember, but your mom and dad could tell you about when you first started counting. And we're all math majors and math minors and really good at math. So I'm sure our families thought that we were just little geniuses because we could count to 100 when we were just like 1 year old. Problem is that counting is more than just saying those words. Counting involves the one-to-one correspondence between something that you're counting and those words or those symbols that you're using, or motions or something that's representing how many of those that you've got. If you've worked with children, if you have children, if you've got brothers, sisters, cousins, and you've played with them very much when they were really little, and you put out like 5 or 6 blocks for them to count. When they start learning those words, they'll start counting those, and they'll tell you there are 12 of them there because maybe they can count to 12 today. 2 minutes later, they'll tell you there are 10 of them there, and you haven't even touched them, and it doesn't bother them at all that the number has changed. Well, they don't have that one-to-one idea yet. They're learning their words. They're learning that idea of making the connection, but all of the pieces haven't come together. Well, but this is where we start. This is where mathematics started. And if you go all the way back to ancient Greek mythology, Polyphemus was that one-eyed giant who was the shepherd, and he took care of sheep in a cave. They went to the cave at night, and every morning, as they would leave the cave to go out into the field to graze, he would count them, not with words, but with pebbles. So he had a stack of pebbles on one side of the cave, and he would move one pebble at a time as the sheep moved out. When they would come back in the evening, he would move those pebbles back to the other side. And that way he would keep up with whether or not he had all of the sheep he was supposed to have. If he ran out of sheep before he ran out of pebbles, he knows he's lost some sheep. Needs to go looking for some. If he's got more sheep than he did pebbles, he's got some neighbor's sheep that he probably needs to return. That probably didn't worry him as much as the other option. But this is counting. It was one-to-one. There was a correspondence. He didn't have to have the words, but the words were important. Later on, the words became important. Throughout civilizations, you've had all kinds of connections to numbers, different ways they have been represented. On the left here, you've got a picture of what's called a quipu. I think I'm pronouncing that pretty well. It is from the Incan civilization in South America, and they used these cloth pieces. They were made out of cotton or wool or maybe some kind of plant fiber, and they were strung together. Then they were dyed. They were changed in different ways. These strings hanging down had different textures. They were separated in different ways. But look at the knots that are there. There's one that hangs down, one, if I count from the top, from the left, 1, 2, 3, 4, 5, 6, 7, 8. I'm not real sure. There are a couple there that are kind of together. There's one that kind of hangs down and doesn't get intertwined with any of the other ones. And notice it's got 4 places along that string where it's got knots in it. Well, those knots represent numbers. And the Incas used a base 10 system. Well, they used powers of 10. It wasn't a place value system, but they used powers of 10. So if you happen to look, if you're looking at that same string that I am, there's kind of a big fat knot near the top. And then maybe about halfway down, there's another one. About 3/4 of the way down, there's another one. And close to the bottom, you've got one more knot. That one at the bottom would have represented how many ones they've got. Then as you move up, how many tens? Then as you move up, how many hundreds? Then as you move up, how many thousands? And the colors of it, the way they're organized, the way they're interconnected. Notice some of them are knotted together, mean different things. They might mean different places, different people, different objects. And then these are shared within communities, within towns. There was somebody who had his job, the profession of this person was to create these quipus to keep up with numbers and document what was going on in the government in the towns. The Advent calendar is much, much simpler. If you celebrate Christmas, you might have one of these in your home. And on December 1st, you put this out. There's one candy or one toy in each one of those places. And it's really a countdown. You're counting the days until Christmas. So 1 to 1, one candy for one day. Also interesting is looking back at the words that we use for different numbers. And 2 is one that I think is really interesting because we use that number, we use different words to represent 2 depending upon the circumstances. So if you've got 2 horses, sometimes you might say a team of horses. 2 partridge, a brace of partridge. 2 shoes, yeah, we say 2 shoes, but we also say a pair of shoes. Well, you don't usually say, well, I've got a pair of plates. No, you say you've got 2 plates, not a pair of them. So that's kind of interesting to think about those other words that we use that have a numerical connotation with them. There are civilizations that use body parts to represent the number amounts. So in Papua New Guinea, which is just north, it's an island on an island north of Australia, there are communities in Africa that do similar kinds of things, where if they wanted to say 5 of something, I own 5 dogs, I would use my right thumb instead of the word 5 and just say whatever the word is for dogs. So if I did children, that means I've got 12 children, which I don't. But interesting to see that. And now I don't know what happens when you get more than 22 children in a family when you've got, I mean, you've run out of body parts at that point. Maybe you just stop counting or you start distributing them to other people. Chinese abacus, there are lots of different devices that we use to help us with counting. So you might remember an abacus that was in your classroom when you were in elementary school, and they look different. There are different types of abacuses or abaci. And this one, you've got one stem below that horizontal bar. The beads above represent 5. So if you look on the far right-hand side, see where I've got 5 beads on the bottom that are pushed up? That represents 5. That would be represented in the same way as if I pulled them down and pulled one from the top down. So go to the third one from the left. Here's my ones place, my tens place. Here's my hundreds place. I've got one of those beads sitting on top of the bar. That represents 500. One of those beads underneath it is sitting next to the bar. It represents 100. So together that's 600. And I'm sure you've seen an abacus where instead of the bar there that separates 5s and 1s, you've just got 10 beads on each of those rods. Different civilizations have different numeration systems, and some civilizations actually have multiple numeration systems. India, Egypt, Mesopotamia, China all have good examples of those where there were such long civilizations over so many years. They made changes, they made improvements based on the mathematics, based on their technology, based on what they were writing on, all kinds of reasons why they would make changes. Geographical influences or influences from other cultures. One of the things that we'll see in these civilizations that we're going to look at, they have some common features. They all have something unique about their mathematical development. They all are from relatively warm climates, fertile lands. Well, you'd kind of expect that. You need some place where you can grow crops so that you've got food. Developed around major rivers, you'd expect that for water. Strong centralized government and religious life, that might be a little bit of a surprise. Part of the reason for that is because the governments and the religious life led to mathematical developments. And we'll see that in some of our discussions in some of our later modules. Okay, the Egyptian civilization is the first one that we're going to look at. For each one of these, I'm giving you a map just to give you a sense of where this is in the world. Of course, you know where Egypt is. There's the Mediterranean Sea, bottom right-hand corner, southeastern corner of the Mediterranean Sea. There's Egypt. Easy to see on the map, the Nile River. It is so large, it flows north into the Mediterranean. There at Cairo, it starts to split. And you can see up there on the Mediterranean, see the city Alexandria. It's going to be an important city in some of our discussions later on. It was a center of intellectual development, intellectual work in mathematics as well as science. The Egyptians are one of those civilizations that had two writing systems. The hieroglyphics we think of maybe mainly with them. It's interesting because of the little pictures that they drew, very primitive. And of course, different people would have different drawings, just like we all have different handwriting styles. They would have different drawing styles. But these are the symbols that were used to represent the numbers from 1 through 1 million. So you've got a different symbol for each power of 10. 1 million is the figure of a god with arms raised above his head. 100,000 is the frog. 10,000 is the pointed finger. 1,000 the lotus flower. 100 is the scroll. 10 is a heel bone. And 1 is just that one rod. And to create a number, you just use as many of those as you need. So if you needed to write down 999,999, you would need 9 toads, 9 fingers, 9 flowers, 9 scrolls, 9 heel bones, and 9 ones. That's a lot of writing. So you can see how this is really easy to learn, easy to work back and forth between our system and their system, but it's not very efficient. It would take up a lot of room. Now, the one thing about this, because it is so easy to write with, is that you could vary the way you're putting these numbers together. Sometimes they were written with the small places on the left, with the ones on the left. Sometimes the ones were on the right. Sometimes they stacked some things up. So like if you needed 900s, rather than put 9 scrolls side by side, you might make 3 rows of 3. So, just personal preference. Easy to interpret. The 3 lotus flower is just a matter of, do I remember which one of these stands for which one? The lotus flower is 1,000. The scroll is 100. The heel bone is 10, and the rod is 1. So that's 3,244 on top. And then the next number, the pointed finger, is 10,000. So 21,237 is that next one. One of the things that's interesting is to go through and just Google on Egyptian numerals, and you'll find them in different places. You'll find them on tombs, on pyramids, on buildings, on walls, and you can start to make sense out of some of those. So here's an example of one. This is part of a wall that is in the Louvre Museum in Paris. And in that third column from the left, kind of near the bottom, you see the scrolls. So those are 10s, kind of look like snails, but I've got 6 hundreds. And then just below that, I've got 2 1s and I've got 2 10s. So that little cluster would represent 622. And notice how sometimes hundreds are turned one way, sometimes they're turned the other way. But obviously it's a scroll. Obviously it's meant to represent 100. The Rosetta Stone we'll talk about more in the Egyptian module. It's really important in helping us understand and interpret these hieroglyphics. It was discovered by Napoleon's army in the late 1700s. Hieratic numerals, this was the other type of numerals and writing that the ancient Egyptians had, a little bit more sophisticated than the hieroglyphics. This is a page out of the Rind papyrus. You can see it has something to do with geometry because you've got triangles on there. One of them looks like a trapezoid over here in the middle on the left, and then you've got, looks like things are labeled in there. All right. Let's move on to the Mayans. The Mayan civilization was in Central America. So we're talking about southern Mexico down into Costa Rica and Panama, this part of the world. And they used a place value system. That's why I chose them. Just like our system is a place value system, theirs is a place value system, but they didn't use base 10, they used base 20, and it wasn't a pure base 20 system. Theirs is a little glitchy. Oops. Now the Mayan numerals, a base 20 system needs 20 numerals for 0 through 19. Then when you get to 20, you're going to represent it with the symbol that you've got for 1. You'll need a 1 and a 0 for 120 and 0 ones. All right. The Mayans had a 0. That's impressive. That's pretty advanced to recognize that they needed that symbol for 0. And then they just used dots and dashes to represent the numbers from 1 to 19. Easy to pick out what the code is. A dash represents 5, a dot represents 1. And then they combined those to create their numerals. Now, if you were to go out into the jungle in Honduras, and you would come across this stela that has Mayan symbols on it, you might be able to recognize some of the Mayan numerals, but they were written or they were carved vertically. So we're used to seeing things going this way horizontally. Theirs were vertical. So here are 2 examples. First, look at the one on the left. Now, the ones place was on the bottom. So in the example on the left, I've got 3 bars and 2 dots. 3 bars, that's 15, 2 dots, that's 2 more, so that's 17. That's in my ones place. That means 17 ones. This is a base 20, so when I move up, my next place is the 20s place. I've got a bar and a dot. That means 6, so I've got 6 20s. I move up a place. Now here's where it gets glitchy, because you would expect that to be the 20 squared place, 20 times 20. But no, the Mayans wanted 360, so they forced the issue. They made that place be 18 times 20. 360 is an important number in mathematics, astronomy, in their science, in their math. And so, I mean, think 360 degrees in a circle. So 360 days in almost 300, close to 360 days in a calendar. A calendar year. So that was an important number. So in that third place, it wasn't 20 times 20, it's 18 times 20. From there on out, you just keep multiplying by 20 powers of 20. So in the top row with the 1 dot, the value of that row is 18 times 20 times 20. And then above that, you'd have 18 times 20 times 20 times 20. And everything higher, you just multiply by 20. All right, so when I figure out what that represents, what that column of dots and dashes represents, I would just figure out the value of each of those dots, dashes, the value of each numeral, and then multiply it by its place. So starting from the top, I've got 1 times 20 times 18 is 360 times 20, 1 times 7,200. And then I've got 3 times 360. And then I've got 6 times 20. And then I've got 17 times 1. And I just add all those up together and I get 8,417. Okay, pretty easy. Then moving on to the other example. Again, I've stumbled onto this pillar and I've found this carved in the side of it. So I need to interpret it. Now, I don't know what they're counting, but I can tell you what the number is. And this one uses some zeros. So in the ones place, I've got 9. I don't have any 20s. I've got 13 360s. I don't have any 720s, but then I've got 7 144,000s. So when I do all my multiplication and addition, add that all together, I get over a million, 1,012,689. Okay. Here are some artifacts from the ancient Mayan civilization, and you can actually see how they're using and where they're using those symbols. So in this eclipse table, this has to do with their astronomy, which was connected to their calendar. You can see the importance of the numbers. I mean, it's real easy to pick out numbers down through here. And in some places, I've got some 2-digit numbers, some places some 3-digit numbers, but I could tell you what, I don't read the rest of the Mayan symbols, so I don't know what they mean, but I can tell you what the numbers are. This I just think is really neat. I just like this number. The Mayan pyramid, and this is one of the most famous Mayan pyramids in Central America. This is one that if you're a visitor there, you can actually climb all the way to the top. It's a square pyramid, just like those in Egypt, but it's truncated. The top of it is flat. That top part is lopped off so that you've got a flat top. On each side of that pyramid, you've got a stairway with 91 stairs. So that's a total of 364 stairs. Add in that top platform, that's 365. And that just happens to be the number of days in their calendar. Doesn't sound accidental to me. Again, the Dresden Codex, this one lives today in Dresden, Germany. But again, you see some of those symbols, looks very much like those that you saw on the tablets before. The Babylonian Empire, again, a very long time, over hundreds of years, a large empire stretched all the way from India over into northern Africa. And the Babylonian and the Egyptian empire overlapped. There were times where there was this land in the middle where the Egyptians controlled it. Then the Babylonians came in, then the Egyptians came back, then the Babylonians came in. So, just went back and forth. And you see influences of both of these civilizations throughout this area. So there's where we are. Some really special features of the Babylonian system. And again, we're going to study the Babylonians again, and module after next. They were pretty amazing what they were able to do when you think about how many thousands of years ago this was. This was a base 10 system, and it was purely base 10. I'm sorry, it was a place value system and pure place value base 60 sexagesimal. Ours is base 10 decimal. So base 60 sexagesimal, no glitches in there. Everything was a power of 60. They wrote their numerals on cuneiform, in cuneiform. That's what they called the symbols. So the Egyptians used hieroglyphics and hieratic. Babylonians used cuneiform. Egyptians wrote on papyrus. Babylonians wrote on clay tablets. And we've got a lot of clay tablets. A lot of them are broken, but we do have a lot of artifacts from this civilization. These things are thousands of years old. Now, they didn't have a symbol for 0, which made it a little bit dicey sometimes understanding and figuring out what their numerals exactly represented. Couldn't really tell what they represented without some kind of a context around it. Okay, there you go. Some other kinds of things that we'll be talking about a little bit later on. There's a picture of a tablet. You can see part of the problem with the clay tablet. Nice thing about it, it's nice and hard. It's going to last a long time, but it also gets dry and it breaks. And, you got a lot of battles going on around here. Things get dropped. Even on a good day, things get dropped. So you've got pieces here, you've got cracks where some of the information is lost. But if we could get really close in there, we could pick out some of these numerals, and this is what they look like. So these cuneiform numerals, we would expect to see 60 symbols, but remember early on, the Babylonians didn't have a 0. Later on, they did. So later on, there were 60 symbols in this list. They made all 60 of these numerals from 2 little symbols. And they used a stylus, kind of like a pen with a sharp end of it. And depending on how they turned that pen, they would get these 2 different symbols, the 1 for 1 and the 1 for 10. The 1 for 1, I think it looks kind of like a golf tee. And the 1 for 10 looks kind of like an angelfish to me. So that's the way I talk about them when I'm talking about them. But it's from the same tool. They're making their marks in wet clay that is then going to get dried. But while it's wet, they can press down into it. And depending on how they are positioning that pen, they're getting these different symbols. And notice when you get over here to 59, that's a lot of little angelfish and tees. Golf tees. They're stacking them up. They're connecting them and stacking them up to save some room. So what would these look like? Well, 2 of the angelfish and 3 of the golf tees, that's 2 10s and 3 1s, is 23. But is that 2323? Or does that 23 mean 2360s? Or does that 23 mean 23 times 60 squared, or just what? Well, I don't really know unless I've got it in context. So if I'm in a museum, maybe I've got something bigger that I can look around it and understand what am I talking about. Otherwise, I'd have to just make a guess. Now, what we're going to do is look at this one, see how I've spaced this one out so that you can see pretty easily that there are 4 digits here, 4 places here. So I'm representing them with our numerals 1, 57, 46, 40. And each of those is in a different place, so they're spaced out. The ones place, just like for us, is on the far right. For them, the ones place was on the far right. Then to the left of it would be the 60s place. To the left of that would be 60 squared. To the left of that would be 60 to the third. So the value of this number would be 1, 2, 3, 4. That's 40 is in the ones place. And then 46 is in the 60s place. So I've got 46 60s. And then I've got 57 in the next place. So that's going to be 60 squared. And then I've got 1 in the next place. That's going to be 60 to the third. And when I do all my arithmetic, I get 424,000. Okay. Oh, just one last thing about this. And on your quizzes, I'm not able to make those little golf tees and those little angelfish to represent those symbols. So I'll be asking you, when I ask you about a Babylonian symbol, if I want you to take a Babylonian numeral and translate it to Hindu, to our Hindu Arabic system, I would write it as 1, 57, 54, 46, 40. I would use the commas to show the different places. All right, the ancient Romans, this is the one that probably we're the most familiar with. The ancient Roman Empire, at its highest point, at its greatest, it reached over into the Middle East. It reached all the way to the Atlantic, all the way across Northern Africa. The German warriors kind of stalled out on their northern expansion, but they did get all the way up into England. So you can see they took up a lot of space. And in these places, you still see artifacts of this Roman Empire. Roman numerals, we know really well. We know that these symbols are represented with letters of the alphabet that are familiar to us. To represent, you might not have known this, but to represent numbers that are bigger than 1,000, like 5,000, 10,000, 50,000, use the symbols for 5, 10, and 50 and just put a bar over it. And that's how they represented things that were bigger than that. I don't know what they did. If they wanted to go bigger than 1,000,000, I think they used 2 bars. So the rules of working with the Roman numerals, sometimes you add, sometimes you subtract. If the values of the symbols are going down, if the big ones are on the left and they're going down, you're going to add. If, and there's an example, M is for 1,000, 200s, 150, 110, and 3 ones. That represents 1,250, 63. 1,263, you just add all those together. Count them in, just add them in one at a time, one symbol at a time. Now, what if you've got a smaller one in front of a bigger one? Well, that's when you subtract. So like if you've got an I and then an X, that means subtract the 1 from the 10. X then I means add it. 1 before X means subtract. So here I'm doing a lot of subtraction. CM, C is 100, M is 1,000. Oh, if I'm reading left to right, then that must mean I need to subtract. So CM means 900. XL, oh, I just went up. I went from 10 to 50, so that means subtract. That means 40. IV, I went up. That means subtract. That means 4. So what did I say that was? 944. There you go. All right, and here's the subtractive principle. You can't subtract 1 from everything, so you never see a 1 in front of an L to represent 49. You represent the 40 and then you represent the 9. So, there are some rules about when you can use that subtractive principle. And here are some examples. So when you get a chance, just go back through. Easy to convert our system to the Roman numeral system. Just do it one digit at a time. Take the thousands digit, then the hundreds digit, then the tens digit. Don't try to get any more complicated than that. Don't try to do 2 digits at a time. Just do one at a time and you won't get messed up with that subtractive principle. We still see Roman numerals. The picture on the top left, I really like. This is from the Roman Colosseum. This is in Rome, and so this is thousands of years old. This was where they went to watch the gladiators and watch the chariot races. And they would go inside the stadium and they would find their seat and sit down. And they had assigned seating. They had section numbers. So this is section number 45. And if your seat was in there, this is the gate that you would go through, or this is the entrance you would go through to go find your seat. Of course, every year we get a new number with the Super Bowl. Lots of times Roman numerals are used to represent when buildings are commemorated or when something else official is commemorated. You might look, if you have on a watch, you might look at it and see if it's got Roman numerals on it. You probably learned Roman numerals when you were in elementary school, at least, you know, some of the first ones, the I, the X, the L, the V, some of those, and C. Also with Roman numerals, it's also helpful because, you know, the C for 100, think of century, think of cent, centennial, all of the places where we've got those connections with our own numbers. All right, well, that's it for that PowerPoint. So you've got that as kind of a basis, and you can refer back to it. You can use the readings that you want to kind of shore up some of the stuff you might have some questions about. Be sure you read through this, think about these ideas, do those homework problems before you do the homework quiz and before you do the reading quiz. All right, I'll see you soon with the Egyptian module. Bye-bye.